Sitomaniemi, and I've been working in Boogie software for 11 years, practically from the first days of operation. First, I was mostly working on Nokia projects, Symbian and Amiga and Meltemi, but after that I started to concentrate on iOS development, which has been my major since like 5-6 years. For this year at the Hackfest, I wanted to do some electronics, and I happened to find a project that interested me. And actually the motivation was that I had this RoboShift device for Amiga, but it had a major flaw. The connector that plugs into the Amiga mouse port here was somehow broken in a way that when I plug it in to the mouse port, it'll actually push the pins inwards in a violent way, and I was afraid that it's going to break the motherboard at some point. So I decided to find something that I can work on for the Hackfest, and I came along this design, which is from Aminet. It's hardware designed by Mark Spankus from 1991. And it's practically auto-mouse joystick switcher design. It's obviously drawn on an Amiga, as you can see from the screen. Before the Hackfest, I decided to do a casing for the switcher. I had already done some 3D printing beforehand for Amiga. You can see that I have this blue plate here that fits the DVI connector, which is then under the hood. It's connected to an Invision AGA graphics card, which practically puts out DVA signal for modern display devices. So I don't need to rely on RF modulator or OSCART. Originally I had just carved my way through the original plate that goes over the trapdoor, and it was rather ghetto design. Some drilling and some knife work. But it was much nicer to get something that was actually designed for that. I found out that AutoCAD has released this educational CAD program called Tinkercad, and I decided to look at that, and actually it turned out to be pretty suitable for my needs. So I ended up then designing this box, which is some 6 by 7 centimeter in size and maybe 3 centimeters in height, and some internal support parts included. And then I printed that with our Prusa 3D printer, and these are all the parts printed out. And then I also decided to paint it with some spray paint. So obviously it needed some sanding and priming and painting, and in the end the result was pretty neat. So it turned out that the design that I found from Aminet was missing a couple of things. When I tested it on the Amiga, it turned out that it was totally random how it worked. It did not really change the channel or the input device when one pressed the mouse button or the joystick button. Instead, it seemed to be changing when you just like hovered over the cables with your hand. So there was obviously something wrong, and what we did then is that we did an audio oscilloscope test on the breadboard elements, and it turned out that there was a lot of noise, and the solution for that was to add a couple of pull-up resistors to get rid of the noise. And after adding those components, it started working. In practice, I ended up wiring the whole set a couple of times because I first didn't notice that the problem was the missing pull-up resistors. And maybe the last bit of lessons learned was that it's not very easy to put things in a small compartment. So what I did at Hackfest is this. So this is the breadboard with all the components, and the size that I'm planning to get it sit into is something like this. So this was the first go on putting up the real thing on this stripe board, but I didn't have the sockets for the chips, and I didn't have all the components needed, and also I think I had enough soldering at that point, so I decided to put that for later. But the final goal is that I'm going to draw this design on a stripe board and then solder it together and fit it into the box that I designed. So how does it actually work then? This contraption here is something that you plug into Amiga. You take the female connector and plug it into the mouse port. And then you can plug a mouse and a joystick to these male connectors. And then when you use Amiga, then you can switch between these input devices by just pressing a button on either of those. So in this joystick tester program, you can see that when I move the joystick and press the button, I can see the directions on the screen, and also the mouse cursor is moving around a bit because it's on the same port now. But when I press the mouse button here, the LED changes, and now I can move the mouse and also press the mouse button to see the button click. And now if I press this joystick button again, moving the mouse has no effect anymore because the input is now controlled by the joystick. Now I can just start playing again some game.